Hello, in this video I will show you how to create your own character in a project on Unreal Engine 5 so that you can walk through your project. The first thing we need to do is bind the buttons that we will use to control the character. To do this, click on Settings in the upper right corner. Here we need to select Project Settings. Next, in this window, in the Engine section, you need to select Input. Here we expand the axis mapping stack, and you need to repeat exactly as I have now. Use the plus sign to create a slot and enter the name. Where we have the keyboard, we enter the key. For example, this will be the E key. And here we see the keyboard section and different keys. We can select the desired key. In this way, we create these values: move forward, move right, and so on. And below them, these keys. Move forward is moving forward and backward. Keys W, S, and up, down, keys on the keyboard. Move right is moving left and right with the keys D and A, as in games. The turn section is for controlling the mouse along the x-axis. The lookup section is responsible for moving the mouse up and down, so we can look up and down. Tone rate is moving left and right with the keyboard arrows. To delete an unnecessary section, I created an extra one, for example, and clicked the trash can button next to this slot, and it is deleted. Once we have bound the keys here, we move on to the next step of creating a character. All these values I may indicate in the description, so you can just copy them. Now let's create a character. To do this, right-click on an empty space in the desired folder in the catalog. And here you need to select Blueprint class. Then select Character. You can name it immediately. I created a character, named it Adam, opened it, and now I need to configure it. First of all, I will create a camera with which we will see everything where we go. That is our movement. Click on Add. And here I type in the search camera. We need not Cine camera, but simply camera. Now let's configure it. Now it is in the center of the character. The character is simplified and made in the form of a capsule. The camera needs to be raised to eye level. In the location field in the transform section along the z-axis, I set approximately the value 60. And we get the camera approximately at eye level. In field of view, we can specify how wide the field of view will be. For now, let it remain 90. Here we can choose the projection method perspective or orthographic. And then a very important checkbox. It is mandatory to check it and not forget. This is use pawn control rotation. That is, the camera will follow the character's rotations. Wherever we look, the camera will look in the same direction as the character. The next step is to program our character. This is necessary to ensure that we can move and rotate with the mouse. For this, we go to Event Graph. Now I will expand the window to make it more convenient. For now, we do not touch these standard nodes. I will go a little lower. And here, we need to create nodes for the values we specified in project settings. We bound the keys there, and now we need to bring them out here as nodes. I search for them. I type exist event in the search. And here you need to output move forward, move right, move rate, and then for the mouse look up and turn. Now I will sequentially add them here. Adding move forward. And also in the search with the same query, I add the remaining nodes. Excellent. I created nodes for our bound keys and mouse. This is for the keyboard. This is for the mouse. So let me remind you that move forward is moving forward and backward. Moving forward and backward is on the keys W and S, or on the up and down arrow keys. So we need to connect the Add Movement Input node. This node will also be needed when connecting to Move Right. Therefore, I duplicate it in advance with Ctrl+D and immediately connect it to Move Right. So Move Right is moving left and right with the keys A and D, or the left and right arrow keys. So now to the Add Movement Input node, we make a connection from Axis Value to the Scale Value channel and do the same with Move Right. That is, we indicate which button will activate this node. So Move Right is the keys A and D, or the left and right arrow keys, and they will activate their Add Movement input. Keys W and S are for moving forward and backward, and the up and down arrows will launch their Add Movement input. Now we need to specify in world direction the direction in which we will move. The direction will be taken from the camera. I bring the camera here, and to determine the direction, I need to take a special node, Get Forward. I need the node Get Forward Vector. I will connect this node to the World Direction channel. We determined the camera direction through the Get Forward Vector node and connected it to the World Direction channel. Now for the Add Movement Input node related to Move Right, we also need to configure World Direction. We also take it from the camera by connecting Get Right Vector to the camera. Get Right Vector from the camera, connect it to World Direction. Target Self specifies who will trigger Add Movement Input. It will trigger for the character. Self means itself. Since we are in the character blueprint, it will trigger for the character. Turn rate is responsible for the left and right keys on the keyboard with the arrows. Here, we need to connect a slightly different node, Add Controller Yaw Input. Search for Add Controller, and here I need to select Add Controller Yaw Input. Connect Axis Value to the Value channel, defining what will trigger, and it will be triggered by pressing the left and right arrow keys. So, we bound the keyboard buttons for moving left and right, forward and backward. I'll comment on them immediately. Select all these nodes and press the C key. Name this container Keyboard Binding. Next, we need to program Input Axis Lookup and Turn, which are the ability to look up and down and left and right with the mouse. For Input Axis Lookup, we'll connect another node. Here, we need the Add Controller Pitch Input node. Also, connect Axis Value to the Value channel. Now, we have made the mouse move up and down. Next, we need to make the mouse turn left and right. This is Input Axis Turn. Here, I need to connect the Add Controller Yaw Input node. Connect Axis Value to the Value, and also comment on these nodes. Select the nodes, press the C key, and here you can enter the name of the container. You can also change the color of the comment. Select the frame, and for example, set this color if necessary. So, we created a character, bound and programmed the control keys. Now compile, save the character, close it, and now you need to create a game mode. To do this in the same place as the character, right-click, select Blueprint class, and here I choose Game Mode Base. Name it immediately. Open this game mode. Maximize it to full screen. And here we need to configure some parameters. Specifically, we need to specify the default character. Find default pawn class, and here select the character we just set up and programmed. For me, it's Adam. Click on it. Now compile, save, and in principle, the game mode setup is complete. Now we need to connect this created game mode to the project. To do this, go to where the viewport is, click on the World Settings tab. If it's not there, you can add it through Window. Let me close it. For example, if it's not there, click Window at the top, and here select World Settings. And it might open something like this. Drag this window to the desired place. And that's it. It sits next to Details. Now in World Settings, find Game Mode Override. Here select our created mode. So almost done. The character is created. Now it needs to be spawned in our scene. Just to be safe, I save. And to spawn it, click the plus sign where we create light, shapes, and everything else. Select all classes, and here I need to find player start. Here it is, player start. I drag it into the project. If it's not visible, for example, like this, it means we hid all elements. Just press the G key on the keyboard and all elements are visible again. Right now, there's an error bad size. This means the character conflicts with the collision. To fix this, you need to raise it above the collision. My floor has collision, so it's conflicting with it. Now set the direction the character will face upon spawn. The direction is indicated by the arrow. Now I'll turn it towards the interior, like this. And that's it, the character is created. Save everything again, and we can check. The project is running. Check the character controls. I'll also explain how to configure the character speed. To do this, go to the content browser, open the character, and here select character movement. Find max walk speed. This parameter sets the movement speed. Currently, it's set to 600. If we decrease it, the character will move slower. If we increase it, the character will move faster. After this, be sure to compile, save, and test. Now let's make the character jump. Also go to Settings. In the top right corner, click Project Settings. Here, go to Input. Expand the action mapping stack. Sub-items open. And here I have jump action, crouch action, and zoom action slots. Each slot has an assigned key. For jump action, which is for jumping, the spacebar key is assigned. For crouch action, which is for crouching, the C key is assigned. For zoom action, the right mouse button is assigned. To create a slot and assign keys, click the plus sign. A slot is created, give it a name, and assign keys here. We write the name of the key in the search and assign it. Now I will remove the unnecessary. If you don't need crouch action and zoom action now, you can skip creating them. For now, we will focus on the jump. After setting everything up, you can close the settings and move to the character. Opening the character. Here in Event Graph, I create jump action by right-clicking, which we created and bound the key for the jump. So we got this node. It has two outputs, pressed and released. Pressed triggers when we press, in our case, the spacebar. Released triggers when we release the key. So when we press, we need the jump to trigger. There is already a built-in function for this, which will simulate the jump, that is, lifting and lowering the character's capsule. We search for jump in the search bar. Great. And for released, when the key is released, we add the stop jumping node. Great. That's basically it. We have created the jump. Now I compile and save. Let's see what we have in the end. I move to the viewport and launch the project. So I press space and we see that the jump works. Everything is great. The only thing is I jump straight to the ceiling, so I think the jump height needs to be adjusted. This is very easy to do. Now I go back to the character. I remove the character moment here, and here I need the jump z velocity parameter. Here I have the value set to 420. I will set, for example, a value of 200 or 250. I compile, save, and let's see what we get. I launch the project, press space, and the character doesn't jump as high anymore. You can adjust it to suit your project. I won't spend time on this now. The main thing is to understand how to do it. Now let's set up crouching. Also, you need to click Settings, Project Settings. Open the settings, go to Input. Here, expand the action mappings stack. We have already covered jump action. Create a slot by clicking the plus sign, name it crouch action, and then assign a key to it. Now I will try to create it again. I click the plus sign, create a slot, name it crouch action. Then click none. Enter the key name in the search, for example C. You can try typing keyboard C. It doesn't work for me. I type the C key. Here we find the keyboard section and there is the C key. Thus, we assign the C key. Now I delete it. Bind crouch action in the same way as I did, and you can close these settings. Now we need to program crouching in the character itself. Go to the character. And here, you need to create a node for crouch action as we did for jump action, through which we will program crouching. I created the crouch action node. This node is created. Pressed is responsible for the event triggered when you press the key, specifically the C key, and released is for when you release the key. For crouching, there is also an already built-in function called crouch. I simply connect the pressed to the crouch node and the released that triggers when the C key is released to the uncrouch node. As a result, we have already programmed crouching. However, this crouching will work roughly, meaning the character will crouch very abruptly. It needs to be made smoother. Secondly, by default, crouching is disabled. To enable crouching for the character, click Character Movement. It's easier to find in the search. Just type crouch. Here, find can crouch. The checkbox is not checked, which means the character cannot crouch. Check the box, save, and compile. Now we need to make it so that the crouching is smooth. To do this, we need to add a spring arm, but we shouldn't just click Add and add it immediately. Instead, we need to attach it to the capsule. For this, click on the capsule. When creating the spring arm, which is like a damping arm, it will be attached to the capsule. After selecting the capsule, click Add, and here search for spring arm. Find spring arm, click, and it is automatically attached to the capsule and becomes a child of it. Now, the camera also needs to be attached to the spring arm so that the camera becomes a child of the spring arm. Just hover over the spring arm and the camera attaches to the spring arm. Now let's configure the spring arm. To make it clearer, we now need to configure target arm length, which determines how close the camera is to the character. To make it clearer, I go into the viewport, and here we will see that the camera is now far from our character. We need to bring the camera back to the place where it was at eye level. To do this, we change the target arm length parameter. I set it to 1 so that it fits snugly to the character. Now for crouching, to make it smooth, we need to enable the Enable Camera Lag parameter in the lag section. Enable Camera Lag, check the box. Here you can leave everything as is. There is also the Camera Lag Speed parameter. If we increase it, we will crouch faster. When necessary, you can adjust this parameter as well. You can also change Camera Leg Max Distance. This is the leg length. I haven't needed this parameter. It seems to work fine by default. That's it. We've set up smooth crouching. Now our character can crouch, and he crouches smoothly thanks to the spring arm. Spring arm is like a hydraulic arm. It smoothly adjusts the value. In our case, it adjusts the height. I compile, save, and we can check what we have in the project. I now press the C key in the project, and we smoothly crouch and stand up smoothly. Now let's figure out how to make a zoom using the right mouse button. For this, we again need to assign a key, namely the right mouse button. To do this, click in the top right corner on Setting. Here you need to select Project Setting, then go to the Input section, and here expand the Action Mapping stack. I already have keys assigned. You need to create a slot using the plus sign, name it Zoom Action, as I did. Then search for the right mouse button key. Bind the right mouse button. After that, you can close Project Setting and move back to the character. Mine is already open. Go to Content Browser, open the character, and we need to call the node where we bound our key. Specifically, this is our zoom action. I create the zoom action node. Here I have two outputs, pressed and released, meaning when we press and when we release the key. When we press the key, I want the zoom sound to play. I already have the zoom sound ready, here it is. Now I will create a node in pressed. So when the right mouse button is pressed, the Play Sound 2D node will be triggered. In the parameter sound, you need to specify the sound itself. To do this, I select the sound in the content browser and click the arrow in sound. The sound is applied to me. Now when I press the right mouse button, the sound is played. Next, I need to implement the zoom. For connecting timeline, it will allow you to smoothly change the focal distance, that is, zoom in and out the view. Connecting timeline. Searching for timeline and naming it Timeline Zoom Time. Opening it with a double click. Specifying the total duration of time for this timeline to work. Specifying not 1 second but 0.9, that is close to 1 second. Then I click on plus track, and here we need to select float track. Creating a float track, naming it FOV. Next, we need to set 2 points, start and end. To do this, I hold down Shift and left click anywhere in the space. Then, selecting the first point. In time, I specify the start time as 0. Then in value, I set it to 90, which is the same field of view value currently set by default in the camera. Next, in the second point, I specify the end time of the timeline, which is 0.9. And in the value, I set it to 45 degrees, meaning reducing the degree to create a zoom-in effect. Now my points have shifted upwards. To fit everything vertically, I click on the button with the up-down arrows. And to fit the width, I click on the second button for convenience. Now it can be saved, compiled. Just in case, you can close the timeline. The timeline is basically ready. Now we need to change the camera's FOV. To do this, we go to the camera we created earlier, dragging its contact closer to the timeline. And here I need to type in the search set field of view. That is, set the focal value. Set field of view, FOV, added to the update channel. Next, FOV is a flow track that we created in timeline. I connect it to the in-field of view channel, which means we set a specific FOV angle. Next, we need to make it so that when we release the right mouse button, the reverse effect happens. For this, connect the released channel to the reverse channel. Reverse the timeline. To conveniently position the cables, I simply double-click on the cable. A point is created, and you can use it to change the cable's direction. If not needed, you can simply delete it with backspace. That's how you can reconnect it. I will also do the same now with this branch from the camera to make the wire look neat. Great! We have made zooming with sound. The sound is not mandatory. I just added it. In the zoom timeline, I specified the time as 0.9 because I adjusted the timeline to the sound duration. Now I compile, save, and we can check the result. Launching the project. Trying to zoom, everything works perfectly. So we covered how to make a character with a basic set of movements. This includes movement, zoom, crouching, and jumping. Like this video to let more people see this tutorial. If you have any questions, you can write them in the comments and subscribe so you don't miss more useful tutorials.